Hey guys, welcome back. Today we're going to be discussing the law of cosines. You may be wondering, what the heck is law of cosines? Well, you can imagine the law of cosines as being like the Pythagorean theorem, where a squared plus b squared equals c squared. However, what's different with the law of cosines is that it's meant for non-right triangles. The formula of the law of cosines is c squared equals a squared plus b squared minus 2ab times cosine of c. Now this won't quite be like how we do other proofs with flowcharts. Since it is an equation, the general proof will be more around showing why each part of this equation is necessary to fulfill the formula. Let's begin. The first thing we want to do is create true right triangles, because in order to perform the Pythagorean theorem, we need a right triangle. So if we create a line segment near the height of the triangle, we can basically separate this triangle into two right triangles. So now we can perform the Pythagorean theorem. Okay, so the first thing we know is that we have two right triangles right now. And I'll just mark it up right now. So we have this triangle right here. I apologize for the bad drawings. And this triangle right here. And these are basically two right triangles because it's splitting down by the height. So it's perpendicular to this line, or what we would call A. Another thing we want to be clear about is we have this side right here, A. However, that's only for this entire length. It doesn't, for this entire line segment. It doesn't account for these two different triangles. So now, what we can do is we can basically say that with this and this, we can call this, like right here, this x, since this whole thing is A. And instead of we need to name this, so we can say this is A minus x, because we're subtracting this from the whole thing, which would equal this line segment. So with that now, we can start creating our formulas for each triangle. So if we want to start with the left triangle, we know that Pythagorean theorem is a squared plus b squared equals c squared. So we know that our hypotenuse is b squared. So we can say that if I just draw this, and here we go. So we can say that x squared plus x squared plus h squared right here, h squared is equal to b squared, because b is the hypotenuse. The second triangle we can create is here, on the right side. So what we'll write this out to be is we know that we have our hypotenuse is c. So we can write that parentheses, a minus x, a minus x squared plus, again we have h squared equals c squared. C squared. So now we basically have the equations for both of these triangles. So essentially now what we need to do is we need to FOIL out this a minus x squared, because we just want to simplify this a little bit. So we can FOIL this out. So we write this as a minus x, close parentheses, and then again parentheses, a minus x, and that doesn't look like subtraction, but that's supposed to be subtraction. And now what we can do is this basically turns into a squared minus a x minus a x plus x squared. Sorry, I know that's a little jumbled up. Okay, sorry. So I realized that I accidentally, when I began to write up the new equation, it was out of the screen. But this is essentially our new equation now. We have a squared minus 2ax plus x squared from our FOILed out version plus h squared from our old equation equals c squared. So now that we just substituted out the a minus x squared. So now what we can do is we can actually, if we look up here, we go, oh, look, there's x squared plus h squared equals b squared. And we actually do have an h squared plus x squared. So what we can do now is we can substitute that out for b squared. So we can write, and I'm just going to switch my color again. We basically write, same thing, a squared minus 2ax. However, instead of x squared plus h squared, we can just write plus b squared equals c squared. So if we write this out again in the form of, just to make it look a little more similar, we can basically write this out as c squared plus b squared, b squared, c squared plus b squared equal minus 2ax equals c squared. So now our equation is getting there. It looks almost just like the actual equation of, so now we still need this cosine, and I'll talk about that now. Okay, so the whole reason we add cosine into this equation, and I'll just redraw our x and our a. So we said before that this line segment would equal x, and this line segment, I'm not going to draw it. I'm not sure I'll draw it. This line segment right here is equal to a minus x. So the thing is that we don't actually, in the real world, we don't really want to go through this whole process of splitting this into two triangles. And so what we do is instead we can use cosine to basically substitute this x and this a minus x. So what we can do now is we can use cosine, and so really what we want to do is we want to use this angle right here to help us find x. So what we can say is the cosine of c. So cosine is equal to adjacent over hypotenuse, so a over h. So our adjacent is x. So we can say that cosine of c, oops, I'll just redo that really quickly. Cosine of c is equal to our adjacent, which is x, over our hypotenuse, which is b. So now what we can do is we can multiply each side by b to get rid of this fraction. And that's a pretty bad multiplication, but I'll just go with it. And times b times b, so we multiply b on both sides. And we end up with the equation, these cancel each other out, so we're left with b times, that's my really terrible times cosine of c equals x. 6. So now we have a substitute for x. So instead of, we can just substitute out in the actual equation x for b times cosine of c. Okay, I just typed this out so it'd be simpler to see. And so now what we need to basically do is just substitute this x for b times cosine of c, since it equals x. So we can write this out as a squared plus b squared minus 2a, and instead of x we say 2ab times, oopsie, why isn't it letting me drawing it there, 2ab, oh my goodness, sorry about that, 2ab times the cosine of c. We'll just put it in parentheses so it's easier. Equals c squared. And there we have our final equation, the law of cosines.